Hello viewers, you're welcome back to my channel. In this video lesson, we are going to look at a very important topic in mathematics which is called surd. And this topic is not only relevant in solving questions in mathematics, but you also find its use in other aspects of science which include physics and chemistry. And most times in the JAM examination, the options are kept in surd form. So understanding surd will help you to arrive or get your answer easily in that type of examination. Or a WAEC and NECO, you'll be told to solve questions and then leave the answer in short form. So having a good understanding or a grasp of SWOT will help you in various aspects of science. So this video lesson is an introductory video into SWOT, and in the course of this video lesson, we are going to look at the introduction or an overview of SWOT, and lastly, we'll look at the various rules or laws of SWOT. Basically, surds are defined as irrational numbers in root form whose values cannot be expressed as whole numbers, fractions, or terminating decimal. Now, there are some key statements in this definition which we are going to look at, and those key statements include irrational numbers, which surd are, then they must be expressed in root form. Now, surd cannot be expressed as whole numbers, so they cannot stand as whole numbers. They cannot stand as fractions, and then they cannot stand as terminating decimal. In fact, these three things here, whole number, fraction, and decimal, are the criteria for determining if a number will be a rational number or will be an irrational number. Now, for rational numbers, you can express them as whole numbers, you can express them as fractions, and then you can express them as terminating decimal. When I say whole numbers include numbers that are not fraction, just like 2, 3, 5, 15, and so on and so forth. Then for fractions, stuff like 1 over 2, 2 over 3, 4 over 5, these are all fractions. Then for terminating decimals are decimals that have an ending. For example, 2.5. If we say 5 over 2, 5 over 2 can be expressed as 2.5. So this one have an ending. But if we take 1 over 3, we keep getting 0.3333. So numbers like this, we call them recurring decimals. We call them recurring because the decimal keep occurring or they don't have an end. So they have what we call a recurring decimals. So for rational numbers, they can be expressed as whole numbers, they can be expressed as fraction or even terminating decimals. So for example, we have the square root of 4. The square root of 4 will just give us a whole number, which is 2. Now the square root of 9 will give us a whole number, which is 3. Now for 25 over 4, the square root of 25 is 5. The square root of 4 is 2. Now when we divide 5 by 2, we end up getting 2.5. Now this decimal has an end. It has a terminating end. So in this case, so rational numbers, they can be whole numbers, fractions, or terminating decimals. But when we come to irrational numbers, we cannot express them as whole numbers. We cannot express them as a fraction that will give us a terminating decimal. So for example, if we take your calculator and press the square root of 2, you end up getting 1.414 with some other decimals that have no end. Or if we try the square root of 0, we also get about 1.732 with some decimals that or a recurring decimal. Now pi is a good example of an irrational numbers. For pi is 22 over 7, ideally, which is a fraction. But when you press this on your calculator, you end up getting 3.142 with some recurring decimals. So in essence, the difference between rational numbers and irrational number just depends on if we can express them as whole number, as fractions, or terminating decimal. So when we talk about so, these are examples of what we are talking about. There are numbers, or they are irrational numbers in root form. In root form, that's as square root, and their values cannot be as whole numbers, just as we have seen here, 1.414. They cannot be as if expressed as a fraction, or they don't have a terminating decimal. So in essence, that is the definition of surds. Now that we have a proper knowledge of surds, we are going to look at various rules of surd. Now these rules guide us on how we solve questions relating to surd. Now the various rules of surd include the addition rule, the subtraction rule, the multiplication rule, and lastly, the division rule. So the first rule we are going to look at in the course of this video lesson is the addition rule. And the addition rule simply tells us that we cannot add two different surds. So let's look at it in this way. If I have one boy and I have one girl, I cannot add both of them to give us two boy girl. So one boy plus one girl will still remain as one boy plus one girl. So this is not possible. But if I have one boy plus one boy, I can add them to give us two boys. So this is possible. So in essence, if your sorts are different, you cannot add them. But if they are the same, boy and boy, you can definitely add them. So in essence, this is a sword A, this another sword B. A is different from B. In this case, I cannot add A and B. So that's why we have this symbol here, which means not equal to. So this means equal to, that symbol means equal to. While this symbol here means not equal to. So it means that you cannot add A and B as a sort to give you root A plus B in combined form. So in an exam, when you are given root 2 plus root 3, don't even think of adding it to give you root 5. This is not possible. So your answer in an exam will also be root 2 plus root 3. So for me, I would say copy the question and give it back to them as an answer, and you are totally correct. So let's check. We have root 2 plus root 3. Let's see why we cannot add them. So root 2 plus root 3 cannot give us root 5. So when you take your calculator and press the square root of 2, you end up getting 1.414. And when you press the square root of 3, you end up getting 1.732. Next, when you press the square root of 5, you get 2.236. Now, when you add up these two together, you end up getting 3.144. And now you can clearly see that 3.144 is not equal to 2.236. So that's why in surd addition, you cannot add two different surds. But when they are the same, like the case of a boy and a boy, you can end up having two boys. So this root A plus root A. Root A is just like one, there's an invisible one here. One root A, there's an invisible one here. So just like one orange plus one orange, we are going to end up getting two oranges. So if we have root 3 plus root 3, our answer in this case will simply be 2 root 3. Also, in this case, we have 2 root 5 plus root 5. There's an invisible one here. So 2 plus 1 will give us 3 root 5. So answer to this second question is 2 root 5. Now, taking a look at the last question, we have root 3. Root 3 is different from root 5. But this root 3 is also similar to root 3. So I can just rearrange it. I'm going to have 3 root 3 plus 2 root 3 plus 2 root 5. Now I can add these two together, root 3 and root 3, because they are similar. So 3 plus 2 give us 5. So that will be 5 root 3 plus 2 root 5. So at this point, you cannot progress beyond this point. So this is going to be your final answer, 5 root 3 plus 2 root 5. So the next law we are going to look at is the subtraction rule. And the subtraction rule is similar to the addition rule in the sense that you cannot subtract different surds, or you can subtract similar surds. So if we look at this, we have root A minus root B, and A and B are different. So it is not possible for us to subtract it. So if we are given a question, let's say root 5 minus root 3, your answer in the example will also be root 5 minus 3. Again, copy your question as an answer for them. So let's check if that's true. Now we have root 5 and we have root 3. Root 5 minus root 3 cannot give us root 2. So root 5 is 2.236, and then root 3 is 1.732. Now root 2 is 1.414. Now when you subtract these two, 2.236 minus 1.732, you end up getting 0.504, which is not equal to 1.414. So again, you cannot subtract different. So, but if they are the same, like we have in this case, root A and root A, they are similar. So we can subtract. Now there's an invisible one at this point. So 3 minus 1 will give us 2 root A. Now, if you look at the example right here, we have root 3, we have root 3. Now, 7 minus 2 give us 5. So that will be 5 root 3. So just like 7 mango minus 2 mangoes. So this will end up giving us 5 mangoes. Now, taking a look at the other example, we have 10 root 5 plus 2 root 3 minus 2 root 5. So again, this is root 5 and this root 5, they are similar, but this is totally different root 3. So I can just rearrange it. So I have 10 root 5 minus 2 root 5 plus 2 root 3. Now root 5 and root 5 similar. So I can now subtract these two. So 10 minus 2 will give us 8. So that will be 8 root 5 plus 2 root 3. So at this point, this will be our final answer because we cannot proceed. This is root 5 and then this is root 3. So the third rule we are going to look at is the multiplication rule. And this rule is different from the addition and subtraction rule, which we looked at earlier, in the sense that for addition and subtraction rule, you can add or subtract if they are similar, but you cannot add or subtract if they are different. But in case of multiplication rule, you can multiply if they are similar or if they are different. Now, there's no obstruction to the multiplication rule. Now, if we look at root a times root b, we can end up multiplying a times b to give us what we have here as ab. Now, for the second one, it's an interesting case in the sense that if we have root a times root a, now we can take a root. Now, a times a will give us a square. Now, the square root of a square is just like the square root can cancel out this square. So at the end of the day, we are going to end up having a. So when you have two similar surds, a and a, just pick the number as your answer. So now let's take a look at this fourth example. We have root 4 times root 4. So I can explain this particular rule. Now root 4 times root 4 is just like taking a singular root and then 4 times 4 will give us 16. And when you have the square root of 16, that is going to be equals to 4. So without wasting time, if you have an example like root 3 times root 3 in an exam without solving or without even thinking too much, your answer is definitely 3. So now let's take a look at this example. We have root 2 times root 3. Now root 2 times root 3, just taking a single root, 2 times root give us 6. So the answer to this question is 6. Similarly, in the second example, I have root 5 times root 7, and 5 times 7 will give us 35. Now, when you take a look at the third example, there's something unique about this. In this case, you will have whole numbers outside, and then you have a surd inside the root, and whole number here and a surd. So what you simply do is that you multiply the whole numbers together, and then multiply the surds together. So the whole numbers will be multiplied together, and then the surd will multiply together. Now, 3 times 2, which are the whole numbers, will give us 6. Root, then the surd, 2 times 5 will give us 10. So the answer in this case is 6 root 10. Now, for the last example, the same rule apply. Multiply the whole numbers. The whole numbers are 6, 2 and 3 rather, and 2 times 2 will give us 6. And then for this inner part, which is the surd, now they are similar again. Root 5 times root 5 without solving is 5. But if you want to solve, root 5 times root 5 is square root of 25, and then square root of 25 is 5. But just simply remember that when they are the same, just pick your number, and then 6 times 5 will give us 30. So that's the answer to that question. Now, for the division rule, it is also similar to the multiplication rule in the sense that you can divide if they are the same or if they are similar. We have square root of a over square root of b. So in essence, you can just bring them together and give them a single root. So this becomes a over b. So just like two friends, they can choose to come together and then have a single shelter or an apartment. So that's what we have here. Now, if we look at this example, we have square root of 35, we have square root of 7. So these two friends can choose to come together and then share a single root. So we have 35 over 7, and then 35 divided by 7. If you press that in calculator, you end up getting 5. Now, for example 2, it's also very unique in the sense that you have an whole number outside and then a surd inside. Whole number here and then a surd here. So again, you play with your whole numbers together and then play with your surd together. So for the whole number, we have 10 outside 2. So we are going to divide 10 divided by 2. We give us 5. Then we have a root rather. We have a root. Now, 8 divided by 2 gives us 4. So we can take the square root of 4, and the square root of 4 is 2. So square root of 4 is 2. So 5 times 2 gives us 10. So answer to this question becomes 10. So it's just very basic. Play with your whole numbers as whole numbers. Then play with your surds as surds. So viewers, I hope you learned something from this video lesson. Don't forget to give this video lesson a thumbs up, and also do it to share this video lesson with your friends so that we can all learn together. And if you have any question, comment or suggestion, do it to leave them in the comment section beneath this video lesson. And if you haven't subscribed to this channel, do it to click on the subscription icon and also turn on the notification bell so that whenever I release a new video, you always get notified. So till you get to see my next video, do have a wonderful time.